Hi friends, welcome back. Today we are going to solve one important HackerRank coding challenge, IMA's supercomputer. So before we start looking into this important coding problem, I want to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find lots of helpful videos that you can use to prepare well for your coding as well as Java interview rounds. For example, there are more than 450 different varieties of coding problems solved and explained with examples on this channel. Many of those problems are taken from previously asked coding interview questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big companies. Among those solved coding problems, you will find all different important coding questions varieties are covered there, including breadth first search, depth first search, matrix problems, graph problems, coding questions related to binary search trees, linked list, strings, optimization problems, as well as lots of data structures related problem that includes important data structures such as stacks, queues, priority queues, hash table, hash map, tree map, hash set, tree set, and many other important data structures related problems are also covered. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this channel can definitely help you in your interview preparation process. So please subscribe to this channel now. Also, whenever we come across any important coding problems or coding challenges, we create videos on this channel so that we can discuss more about the problems, the approaches, the logic to solve those problems along with the Java solutions, so other people can also learn how to solve different varieties of problems. So make sure you click on the bell notification icon so you won't miss any important videos from this channel. So let us start with this problem, IMA's supercomputer. So I have already given you the link of this HackerRank challenge. I'll also add this link into the video description. So IMA build a computer, a quantum computer. Help her test its capabilities by solving the problem below. Given a grid of size n by m, each cell in the grid is either good or bad. A valid plus is defined as the crossing of two segments, horizontal and vertical, of equal lengths. These lengths must be odd, and middle cell of the horizontal segment must cross the middle cell of the vertical segment. Find two largest valid pluses that can be drawn on good cells in the grid and return integer denoting maximum product of their areas. In the diagram below, the blue pluses are valid and orange ones are not valid. And also they are saying that these plus signs that they are asking us to find out in the given grid, they should not overlap each other basically, right? They should not cross each other basically or overlap, right? And they have given us some diagram to show us what is a valid sign, plus sign, and what is not a valid plus sign, right? So blue is valid here. So this is the example. So as you can see, so these are blue signs which are valid signs, right? So this is valid sign, this is valid sign, this is also valid sign, right? This is not valid sign, this is also not valid sign, this is also not valid sign. So these plus signs are not valid signs. So it is only valid if it starts at a middle one and it has a odd length basically. For example, this length here is 3, right? So this is odd length, right? And this is also 3, this is also odd length. So this is a valid plus sign, and they are intersecting in the middle cell, right? So this is a valid plus sign, this is also valid plus sign. Why? Because this length is 5, right? And this length is also 5, correct? So this is odd number, so it should be odd number, and they are intersecting in this middle cell. Then these are the valid signs. This one square itself is a valid sign of one size, right? And you can calculate the area of this valid sign. So for example, for this one the area is 1, right? For this one the area is 5. How many squares are there? 1 2 3 4 5, right? For this one the area is 9, right? Because there are 9 squares here, correct? And these are all invalid cells basically, invalid square signs or plus signs, sorry, plus signs. So if you take a look, they have given us some examples here. So this is one of the examples they have given us. So let us understand with this example, then I also will show you one example that I created. So what they are saying is they are going to give us a matrix, basically 2 by 2 matrix, right? Here 6 by 6 matrix is given. G is a good cell basically, right? G is a good cell, and B is a bad cell, right? B is a bad cell. So now we have to find out plus signs that is formed using good cells, correct? So now let's just first visually look into this problem. So now if you visually look into this problem, then you can see that there is a plus sign like this. You can make a plus sign here, right? Like this, correct? This is a plus sign, right? And this is a valid plus sign. Similarly, you can make another valid plus sign here like this, right? Because it should always like it should contains all good cells only. It should not have any B, right? So these are all G's, and we cannot expand it more basically, correct? So this is another square that we can form, correct? This is also a square which is possible, but it is just a one length square, right? So it will give a small area. So we wanted to find out two squares. The goal of this to solve this problem is two squares we have to find, right? But how two squares, which will give us the maximum area, maximum product of the area, right? Maximum product they should give. So now if I take these two squares, this area is 5, right? This area is again 5, so I can get 25 actually as a product of the area, right? So this is what the problem is asking us to do. And upon one more important thing is these two squares should not overlap, right? They should not overlap, no overlapping, right? Means they should not cross each other basically, no overlapping basically, right? So now as you can see, these are separate, they are not overlapping with each other, so this is valid squares. So this is what the problem is asking us to find. So now this is one example that they have given us. I created bigger example than that. So this is another bigger example I created. This one is a 10 by 10 matrix, right? 10 into 10 matrix. Now I have highlighted for you the two possible largest square in this matrix, right? This black is one largest square. How much is the area of this one? The area of this one will be 9, right? And this area is also 9, correct? uh, 1 2 3 4 5 6 7 8 9, right? So these are two possible squares. So basically we have to find out these squares, right? And uh, in such a way that they should not intersect each other, and they should be made up of all good cells, right? G basically, G is for good cells, right? So they should not have any B basically, correct? So how will we solve this problem? So what we will do is, let's just discuss with this example. So what we will do is, we will actually, whenever we see G, we will try to expand in 4 directions. For example, if let's just assume that we are here, let's say we are here, let's say, right? We are here, and it is a G. It means that this is a good cell, right? So it is possible that this can be a part of a square now, correct? So now we will try to expand it in 4 directions. We will go in 4 directions, here, then here, all these 4 directions, right? Up, what are 4 directions I am talking about? Up, down, left, right? These are the 4 directions. So now these are up, down, up, down, left, right? Now these are all G's, correct? So now we have expanded it one time, correct? Expanded it in 4 directions one time means how many more cells we got? We got 4 cells basically, correct? If I expand it one time. Now I will try to expand it one more time basically and see if that expansion is possible. So here I will expand, right? 1, then this is 2, then this is 3, and this is 4, correct? This is 4. So this is also possible because all are good cells, right? So this is my second expansion. Second expansion will add 4 more cells, correct? So now how many total cells I got here? 4 plus 4 plus 1. Why 1? Because for the middle one, right? So total 9 cells I got here, for example, right? 9 cells I got here, right? Now after this point I cannot further expand because this is end, right? Here it is end, so I cannot expand it more. So this is the maximum expansion which is possible, correct? So this is the way we will actually, whenever we find out any G cell or good cell, we will try to expand in 4 directions, and we will keep track of the area, right? We will keep track of the area that we are getting basically, correct, or number of cells in the plus sign that we are getting, correct. And once we see any plus signs, we will also change this G into V, right? We will change this character G into character V. V means visited. Why we are doing that? Because we want to make sure that the next square or next plus sign that we are going to consider should not overlap with this one, right? Should not overlap, right? So to avoid overlapping, then we have to change that sign to V, right? This G we will change it to V. It means that that plus sign we have already considered basically, correct? So that's why we will have to change that to V. So now similarly we will do it for other cells also. Now when I actually, like for example, when I let's say when I go here again, let's say if I am here, right, again I will try to expand in 4 directions, because expansion is possible, right, because all are G cells, all are good cells. So this is my first expansion, right? This is the first expansion. So in first expansion I get 4 more cells, right, good cells. This I'll again try to expand if it is possible. So it is possible because all are good cells. So this is 1, this is 2, this is 3, and this is 4, correct. This is again possible expansion for me. So now I got second expansion, right? I got 4 more cells. So total how many cells I got in this plus sign? 9 cells I got, correct. 9 cells I got. Now I cannot do any more expansion because this actually I am at this end, so I cannot expand it, and this G also would be actually become V, because once we expand it we will convert it into V, correct, so that we will avoid the overlapping, correct. So this is the approach we will be using to solve this HackerRank IMAS supercomputer coding problem. One interesting coding problem I came across, so I just thought that it's worthwhile to create a video and explain you how we can solve these kind of problems. So this is a matrix related problem. So they have also given us one example here. So this is how we will solve this also. We are again going to be expanding in 4 directions, correct. So now they have shown us the plus signs here, right? This is the first plus sign in blue color, right? This is the second plus sign. This is the maximum length plus signs, right? So we have to find out two maximum square, like two maximum size pluses, right? Two maximum size plus signs basically, right? Plus signs, and then we have to multiply their area basically, correct, to find the answer. So I hope now you understood clearly how we are going to solve this coding problem. So let's go to the code. It will be more clear once you look at the code. So this is the, like, I just created a grid here, right? The grid is the same grid that I shown you here. This is the same grid, and we are just going to call the two pluses method that we have to implement. It returns the total area maximum, and uh, first we are going to calculate the total number of rows in the grid and total number of columns in the grid, right? Total number of columns in the grid. So we will take two variables here, square1 and square2, and we will create a array, correct, of same size as the total rows and total columns. Why we are using it? Because whenever we want to visit that cell as a plus sign, we want to keep track of what cells we already have considered when we have seen some plus signs, right? For that reason we are creating this array, and it is of the same size as the original matrix, correct? Total rows by total columns. Now after that we are creating two variables, max1 and max2. This is to keep track of the maximum plus signs that we have seen, right? Maximum two plus signs, correct? Maximum two plus signs. Okay, now in these two for loops what we are doing is we are actually populating this array with the same as the original grid. So we are making it, this is now initialized as the same as the original grid, correct, as you can see here, right? So now after that we will start iterating through the given matrix, right? We will start going with like the, because max 1 is already considered as a 1, right? So we will start iterating through the original matrix at position 1, right? And then we'll go until total rows minus 1. Why we are using position 1? Because this 1 is already considered, right? It cannot be more than that, right? So for that reason we will start at position 1 and our max is already assigned as 1, right? So it means that that's why we are starting at 1. Okay, so now what we are doing is our position is 1, result is 0. Now here in this while loop what we are doing is we are checking if expansion is possible at that cell, right? So what I mean to say is I'll remove this color so I can reuse this space. So now what I mean to say is, let's say we go in this cell, right? So we will check if this is a valid cell and expansion is possible. So this is not a valid cell, right? Because this is a bad cell. So let's say we go here, correct? We go here, right? And we want to check this is a good cell, so we want to check if expansion is possible. So how we will check? We have to go in 4 directions: right, down, left, and up, right? Up. And if all of them are good cells, then expansion is possible. So this is what we are going to be checking here, right? So in this while loop, that is what we check. So I minus position is greater than 0, I plus position is less than total rows, right? And j minus position should be also greater than 0, means those should be valid cells, right? And then uh, j plus position is less than total columns, correct? So those are valid cells inside the matrix. They should be in the boundary of the matrix. And after that, this is where we are actually going in 4 possible directions, right? I minus position j is one direction, I plus I j minus position, I j plus position, and I plus position j. So basically what this, I'll highlight this. What we are doing in this highlighted part is we are going in up, down, right and left directions, and we are checking if all these directions are good cells. If they all are good cells, it means that one more expansion is possible. I hope you are following this. Again I'll repeat, one more expansion is possible. If it is possible, we will come here, we will mark all those cells as visited. So what we are marking visited here, I'll show you that. So we will mark all this. Let's say I'll show you one correct example. So this is our correct example, right? Let's say this is G, right? So we know now that expansion is possible, then we have to change this V to V, right? We are making them V because expansion is possible, correct? So this is what we are doing basically here, right? And why we making them V? Because we want to avoid the overlap, right? That is why, right? And see, whenever we are checking the array characters, not the original grid characters, so that we want to make sure that they should not be already visited, right? That's why we actually check here. I'll highlight this. We are checking the array characters, not the original grid characters, right? The grid character is here. We are not using a grid to check, we are using the array to check, correct? Because we are keeping track of the visited cells by using V in the array, not in the original grid, correct? That's why. So now you understood this, that we actually got one expansion possible. It means that we have expanded 4 more cells, and position will also go position plus 1, right? So now you got 4 more cells. Now position will be 2. So initially position is 1, now position became 2. Okay, so now let's just consider now why 2. What will we do with that 2? It means that now we will go to these 2 positions here, right? Like 2 positions right, 2 positions down, 2 positions left, and 2 position up. We will check these things to see if one more expansion is possible. If all are good cells, it means that one more expansion is possible. Then in that case, again we will add 4 more to the result, right? So we got 4 more cells in the plus signs, right? And we will add position is equal to position plus 1 basically, right? So this while loop will actually expanding the plus sign as much as it can from the given cell, right? Now when we reach here, we have to add 1 here to the result. Why 1? Because for the middle cell, for the middle cell, for this cell we have to add 1, correct? So 1 plus 4 plus 4 in this case we will get, correct, is equal to 9. I hope you are understanding this. So now once we get this 9, then we will just, this is just to show you stack trace. After that we will keep track of the maximum possible square that we have seen. We have to keep track of 2 maximum possible squares. So this is what we are doing here, to keep track of 2 maximum possible plus signs that we have seen, right? So here, that is what we are doing. If square 1 is equal to max 1, square 2 is equal to math dot max between max 2 and result, right? And if square 1 is equal to max 2, then square 2 is equal to math dot max between max 1 and result. So basically what we are doing in this part is we want to keep track of the maximum 2 squares that we have seen so far, maximum 2 squares or 2 plus signs that we have seen so far, correct? So this is what we are doing here in this part of the code, right? So we will keep looping it in the whole grid, and at the end we will find out the max 1 and max 2 that we have to just multiply, correct? And it will give us the total area of 2 maximum plus signs, correct? So this is how the approach is. So let us go ahead and execute this code and make sure it gives us correct answer on this grid. So now we are getting 5 by 5, which is 9, which is the correct answer for this one. We will also, let us just comment this one, and we will also test this original grid also that they have given us. So this is the original grid they have given us, right? So B, 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 G, B, right? So this is the same. So we can create this example 6 by 6 grid example here. So let me just create this B, G, B, B, G, B, or we can take this example, that is fine. This example we can take. So let's take this example, make sure it works. So this one has a one square, it find 5, and the second square it find 1, right? So it gave us area 5 into 1, which is 5, right? So now if I just make it big, I can show you, just a second, right? So this is the grid that we are looking at. So now 5 area it found out here, right? It is finding 5 area here, 1, 2, 3, and 1, 2, no, sorry, it's 5 like this, right? 1, 2, so only one expansion is possible here basically, and this is the maximum area of a plus sign here, right? Without intersection or without overlap. So here, as you can see, this is 1, 2, 3, this is 1, and this is 1. So this is 5 by any G you can take basically. So that is 5 by 1. So one plus sign is of 5 squares, and second plus sign is of only 1 square. And so 5 into 1 is equal to 1 basically, correct? So this is what the output says here. See, 5 into 1, and this is the stack trace. So it is going to each cell and it is calculating the maximum plus sign possible there. So 5 is the maximum one we found, and the minimum, like the next maximum is 1. So 5 multiplied by 1, right? So it gives us correct answer. If we modify this matrix, and let's say if I put a G here, right? Let's say if I put a G here and if I put a G here, correct? So now we will have two different 5s, right? Let us execute this test case and make sure it gives us correct answer. So now, as we know, we have now two plus signs of 5 size, right? So total area will be 25. Why 2? On this G you will see this G, 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 G and G, right? So this is total. So let me just copy this so I can easily show you on a whiteboard here. Okay, so let us just make it big. So I will just highlight you the highlight for you the square, the plus signs. So the plus signs here that we are considering is this, right? This is the plus sign. This is one plus sign. Okay, so as you can see, all good cells, this area is 5, and the second plus sign that we are getting here is this one, correct? This is the second plus sign as we are getting, correct? So all good cells, again this one has an area 5. So 5 multiplied by 5 is equal to 25, right? And they are not intersecting, that is important. They are not overlapping, right? If they are overlapping, we will not consider that as a good cell, right? Like a good plus sign, right? So they are not overlapping, that is why we are getting 25 area for this one. I hope you are following me here. So now these are the square, one is 5, which is the maximum size square. The next square is 5, so 5 by 5 is 25. Square means plus sign, basically it is plus sign, right? So this is the way we can solve this EMAS computer problem on the HackerRank. I am going to add this link to the actual coding challenge where you can go and check out the coding challenge. um, I hope you clearly understood this problem and the Java solution that I shown you in today's session. If you are new to this channel and if you haven't already checked the very important playlist on this channel, then I want to mention that there is a very important playlist on this channel. The name of that playlist is Leetcode and Leetcode Solutions. That playlist has more than 250 different varieties of coding problems solved and explained with examples. Many of them are frequently asked coding questions by many big companies, including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big companies. Go through those videos. There are lots of important coding problems discussed there. You will learn a lot by watching those videos about data structures, algorithms, how to apply algorithmic techniques to solve different coding problems. You will also learn more about problem solving, logic building that can help you in your interview as well as coding interview preparation. So check out that playlist. I'll repeat you the name of the playlist on this channel. The name is Leetcode and Leetcode Solutions. If you are looking for some more coding problems for your practice, then there are three other playlists available on this channel. The names are Code Forces, Code Chef, and AdCoder. All in all, on this channel, there are more than 450 different varieties of coding problems solved and explained. All the coding problems come with Java solution code, where the Java code is available through GitHub repository. You will always find the link to the Java solutions in all the video description section. So check out those videos. You will learn a lot on this channel. We also create videos, relevant videos about Unix and SQL interview related videos that can help others in the interview preparation. So check out those videos as well. That will also help your interview preparation. Uh, if you like this video, if you find this video helpful, if you learn this EMAS supercomputer problem completely by watching these videos, then please give it a thumbs up to this video, give it a like to the video, subscribe to this channel. Your subscription is very important for the channel because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve different coding problems. Through this channel, we wanted to help them by showing them how different coding problems can be solved using different data structures, different algorithms, and using Java programming language. So by watching these videos, you will also learn more about Java programming language, Java programming APIs, and what are the important Java classes that are useful to implement different Java solutions. So if you like this video, give it a like, share it as much as you can with your friends and colleagues so they can also watch these videos and learn from these videos. Um, if you like the videos on this channel, if the videos on this channel are helping your learning process, you are learning something new here, and they are helping your coding interview preparation process as well, then please do write into the comments and let us know how the videos are helpful to you. Your comments are very important to us. That increases our motivation to create more such good quality content. So if the videos are helping you or they have already helped you, then please do write into the comments. If you want us to create any particular video about any specific topic related to computer science or Java programming language, then please do write that into comments as well. Keep coding, keep learning, keep solving different varieties of coding problems, and thanks for watching this video.